Well, Alfred Whitehead understands AI, the fast-changing technology, the opportunities, the applications, the issues of it. Alf is a brilliant techno-geek, and here today to help us better understand the broad landscape of this fast-moving technology, to explain in plain English something that is often hard to understand, is Alfred Whitehead. Thank you.
Good morning, I'm Alf Whitehead. I help life sciences companies figure out how to use AI. But that's not what I'm here to talk about today. Today I want to give you a bit of an introduction, explain a bit about why AI is such a big deal right now. And some of you might ask the question, what changed? AI has been around for a long time. 1940s, it started out with Alan Turing. What changed? Why all of a sudden this hype? And I can give you a one-word answer: transformers. A new technology that's really revolutionizing AI. Now, just naming something, though, doesn't explain it. So what does a transformer do? Well, let's just all do it together. I'm going to say, Mary had a little, and you all said lamb. That's right. That is exactly what a transformer does. It takes a sequence, a pattern. It uses its experience, and it continues it. Now, how did you know I was going to say lamb and not boy? Mary had a little boy is a perfectly good sentence. The answer is you didn't. You used your experience to guess a statistically likely outcome. And that's what transformers do. You give them a starting sequence, they use their knowledge of patterns, and they give you a statistically likely outcome. And this is why we have things like hallucination in AI, where models give answers that we don't expect. It's just picking a likely outcome from what it knows about patterns. And so when you think about it this way, it's not all that surprising that you have these issues. So all the fancy technology really comes down to the game of what comes next. Here's the start, what follows? And every application of AI that you're going to be seeing on stage here today and you're seeing out in the world really comes from this simple, fundamental principle. Another good question is, why now? What's changed in the last few years that has really amplified the amount of investment and interest in AI? Well, 2017, the invention of the transform over at Google and the University of Toronto, that really changed the game in terms of the technology available. And we've had a massive scaling up. I love this chart from The Economist. This is a logarithmic scale, and it shows how much computing power goes into a state-of-the-art AI model. So in the last 10 years, we're up by a factor of about 1 billion. We've had a billion-fold increase in the amount of computing power in these models. And we now have, thanks to the internet, trillions of gigabytes of data that can be used to teach them what patterns look like. And so the convergence of those two factors, the incredible amount of computing power, the incredible amount of data, have really allowed AI to take off. And that's why we're seeing the AI revolution today that we are. I want to talk a little bit about basic capabilities of AI, and then I'll dive into a little bit about how it's being used across many different industries and fields of endeavor. Most of you are probably familiar with the most basic capability, which is that AI can write. So this is me asking Microsoft's Copilot to write a paper on chatbots, which it does. This is the simplest way to use AI. This is the least interesting way to use AI, in my opinion, but it's out there. And this is something that is embedded into software that billions of people use. Microsoft Word now has this feature. Anyone in the world can buy it and use it. Other word processors, email programs, calendaring programs, they're all getting this stuff added. And so this is going to be something that is on the desktop of every knowledge worker within the next year or two. Think about that. Here's a little more advanced example. Here I am having a conversation with an AI. And this is the better way to use AI, is we work on creating the pattern together. And what we're discussing is a data file that contains clinical trials. I'm asking questions. The AI is looking at my file. It's writing computer code. It's running computer codes. There, it just made an error. And we're discussing how to do this analysis. And in about 8 minutes real time, that video is sped up, but in about 8 minutes, I was able to go through every clinical trial on record with the US government and pull out all the ones relevant to women's health conditions. This is something some folks at my company had to do by hand, the old-fashioned way, and it took them about a week. This took 8 minutes. We compared the results. They were comparable. They were not identical. There were some that were, the humans picked, the AI didn't. There were some the AI picked, the human didn't. But all of them fell into sort of the gray area of a judgment call. And so that's something that I think we need to learn as we work with AIs, is that they think a lot more like we do than we're used to thinking of how computers operate. They're not as exact, but they interpret. And the trick is to understand how they've interpreted and how to work with that interpretation. As we saw with Rafiq's presentation, AI can make fabulous art, whether it's beautiful images like this done by my colleague Owen, or video. I'm going to show the same system that Tom Graham just showed. This is Sora from OpenAI. They released this about 2 weeks ago. And what you're seeing in the text here is what is being input. That's the start of the pattern. And the AI is going to continue it. So here's the cat waking up its sleeping owner. This is unretouched AI footage. Pretty much understands how cats work. Here's an image you've seen before. This is the drone footage of Big Sur. Again, all AI generated. It is just continuing the pattern, but the pattern that came in was just that little bit of text. Let's have a look at a bustling Tokyo city street. This is entirely synthetic. These are not real people. This is not a real street. And it's looking pretty good. I want to show this sort of fun example. This is something I built just purely for fun. And what this is it shows how the pattern can start with an image. So in this case, you're going to see the camera roll. It's going to stop. That's the AI capturing an image. And then it's going to describe it in the style of a famous person.
Here we stumble upon a heartwarming scene of camaraderie between species as a human engages in a moment of joviality with their canine companion. The joy shared in their interaction is a marvelous display of the bond that can form across the animal kingdom.
So this was a fun little experiment, right? Was able to see the photo, understand what was happening. It was able to write in the style of David Attenborough. And I was able to steal his voice, which should be a little worrisome. I used that without permission. Apologies to Sir David. And all I needed to create that was one chapter from an ebook he had recorded. And that was enough to clone his voice to that level of fidelity for the cost of a couple dollars. So this is the sort of technology that is out there right now. So let's maybe talk about how it's getting used. Politics. This will be a fun one. Politics, of course, is the art of communication. And AI is going to be incredibly helpful when it comes to developing messages, authoring legislation, understanding how to talk to voters, all of these things. I wanted to show an interesting example of how it can be used for better understanding. Some of you may have watched this interview between Tucker Carlson and Vladimir Putin. Putin was speaking Russian, and the folks at Sync.Labs have used AI to translate him. And pay attention to how well this translation works.
How did you conclude that?
It's not that America, the United States, was going to launch a surprise strike on Russia. I didn't say that. Are we having a talk show or a serious conversation?
Here's the quote. Thank you. It's a formidable series.
Oh, serious. Okay, all right. Because your basic education is in history, as far as I understand.
Yes.
So, if you don't mind, I will take only 30 seconds.
Well, any of you who watched the interview knows that what followed was 30 minutes, not 30 seconds. The other thing you should notice, though, is the AI has done a great job. It hasn't just taken the Russian words and made them English. It's also synced up his lips. It's synchronized to the gestures. It understands the cadence of the speech. It's cloned Vladimir Putin's voice into his English-speaking component. And so this is a great way, potentially, to increase understanding, to bridge gaps in politics. It can also be used for ill. Here's an example from the New Hampshire primary. A number of voters got this phone call.
It's important that you save your vote for the November election.
So that was President Biden telling them to not vote. That is not what we want, but it is very convincing. And these sort of voice cloning things are not limited to politics. We saw a case recently where someone had gathered voice from a young woman, a teenager, and then had used it to create a ransom demand to her parents. And the voice quality was sufficiently good that it fooled her mother into thinking she had been kidnapped. And they were about to hand over hundreds of thousands of dollars when the daughter happened to call them, and everything was fine. She had never been kidnapped. Nothing had ever gone wrong. So these technologies are already changing our world. It's also driving, to some extent, geopolitics. AI requires a huge amount of computing power. One thing that is driving conflict between China and the US is the fact that 100% of the world's top-end chip production, those 4 and 5 nanometer chips that are the very best, is made in Taiwan right now by a single company in a single location. This is something that, of course, strategically we're working to unwind, but today, Taiwan is the most strategically important place in the world of technology because of that. I want to talk about impacts on science, something a little more upbeat. Certainly, science has so much to gain. AI has made huge progress in things like understanding how proteins fold, how to simulate the behavior of many different actors in a system, generating hypotheses, doing administration. I'm going to show one of my favorite examples. This one comes from Google, and if you've ever been a graduate student, you'll relate. This one is about a literature review. So here we have someone who has this plot. It's about how many validated variants of each gene have been published. But it ends in 2020. And she wants to fill in the data to the right. She wants to figure out, oh, what other new things have been discovered since 2020? Well, if you're a graduate student, get ready. You get to spend a month or so reading all of those papers, sorting through all of that literature to find out what matters. She's going to use Google's Gemini system. So what she does here is she writes the start of a pattern, a prompt that tells the AI what to look for. She tests it on a couple of papers she knows, and then she goes for lunch. And it looks at hundreds of thousands of papers while she's away. And then it writes the code to extend this plot. And so it has sorted through all of that scientific literature. It has found all of the relevant papers. It has organized them and handled all of the duplicates and overlaps. And it's used that to connect to the existing data set. This is literally a month of work by hand. And Google, according to them, this demonstration took about 2 hours to run using PubMed. And that's 3 years of PubMed data, so probably close to about 2 million papers, roughly, that it looked at. So that's pretty incredible. There is, of course, a dark side to all of this. I want to talk about this paper, which was the use of AI that was created for drug discovery for ill-gotten gains. So this company had an AI that was trained to maximize the bioactivity of molecules and penalize toxicity. Well, what happens if you flip that arrow and you say, I want molecules that are very bioactive and very toxic? Well, they ran it for 6 hours, and they ended up finding 40,000 molecules designed by this, including the famous VX nerve gas agent, as well as, if you look at this distribution, everything to the right of that red line in this histogram, that's a molecule that the AI thought would be more lethal than VX that was designed. So these scientists, of course, did not publish this list of chemicals. They handed it over to proper security, and instead they wrote about the danger of these models because they're agnostic to the intention that goes into how they're used. Personally, one of the areas I think is going to be a huge area of growth in the next few years is going to be in genomes. The AIs of today, they understand text, they understand images, they understand sounds. Another pattern they can learn are genetics and how that turns into biology. And so once we get these going, I think this plus the synthetic biology revolution we've been seeing is really going to make genetic engineering finally take off. So exciting, but also a little worrisome. I want to talk a little bit about impacts on education. You can imagine giving every student in the world these writing tools, these mathematical tools, has created some interesting side effects. I often think that AI has done to the written assignment what calculators did to arithmetic. You now essentially have a calculator for words. So what does that do to how you educate and how you plan? You need to, of course, teach students the fundamental skills, but you also have to be realistic. When they graduate, they are going to have these technologies wherever they go. AI technology today is the worst it is ever going to be for the rest of our lives. It's only going to improve from here. So understanding how to use it is important. And I think there are some very encouraging use cases from education. This is an example from Khan Academy of an AI that helps teach you math. And here we are. It says, first of all, there at the top, it's going to show everything to the teacher. We're going to have the student ask for the answer, and it's going to refuse. And then the student is going to make a guess. And here they're going to screw it up. They're going to misunderstand the distributive property of multiplication, which is the common error. And the AI not only understands that the student got it wrong, but it understands why the student got it wrong and is able to provide useful, actionable feedback to that student. It's going to help you learn. So this is, for me, I think one of the most hopeful areas of AI, a personalized tutor that's always available for every student, that's going to customize to their level and is never going to get bored or frustrated or be unavailable. I want to talk about an area near and dear to my heart, AI's impact on business. AI is fantastic already today at what I call ritualized communication. Anytime you have business to consumer or business to business, when you're having sort of the same conversation over and over and over again, whether that's insurance claims or advertising or invoicing, all these things are ripe for AI automation. I'm going to talk about an example that came out about 10 days ago from a company called Klarna. They're an online payments company, and they published some data on an experiment they had done. They took, for 1 month, all of their customer service traffic and sent it first to an AI and then escalating to humans if needed. And they talked about the results. The AI handled 2.3 million contacts in that month. It did so in 35 languages. It handled those contacts 82% faster than a human agent would. The average length of the contact went from 11 minutes to 2 minutes. So think about that as a customer. That's a pretty big benefit. And there were 25% fewer recontacts, 25% fewer instances of customers coming back because their issue hadn't been solved. They asked the customers, hey, what's your satisfaction like, as they had been doing for years with their human agents? No change. So Klarna's conclusion from this is that they can reduce their workforce by 700 full-time agents and generate $40 million of net profit annually to add on to their bottom line. We talk a lot about AI taking jobs. This is one of the first concrete examples I've been able to find. And I think when we consider what jobs are at risk, AI today is good at solving tasks. It's good at doing specific things. And if your job is just doing the same task over and over and over again, that's a job that's at risk. And that's something we need to consider. What do we do about this as a society? Couldn't resist showing one little example from my own work. This is a project planning tool we've created that helps our project managers scope work. They write up their scope, and we have different AI agents have a conversation with each other about what they've written. And each of these agents is controlled by a different field of expertise. So we'll have software developers, we'll have regulatory review people, et cetera. And they'll have a conversation with each other, trying to answer each other's questions about the scope to make sure the project has been adequately planned. Anything it can't figure out, it gives back to the human. So this sort of planning ability basically makes every project manager at our company as good as our best. And that's a trend we're seeing with AI rolled out into business. It often helps every employee function at a much higher level, but it helps those who are poor performers the most. And this is something that I think is going to be called eventually the cognitive assembly line. We're creating effectively the industrialization of knowledge work, where all of a sudden the same sort of robotics you see in manufacturing are going to start showing up in how we create work in commerce. So hopefully by now I've convinced you that transformers are a revolutionary technology. This simple game of playing what comes next in the pattern has so many uses and so many unexpected outcomes. And because of that, I think that is why today AI is everywhere and why it is going to remain everywhere. With that, I'll say thank you.
I'll ask you a question, Alfred, if I might, sure. And that is this. You talked about the use of AI in the educational setting, in the classroom and academia. Should teachers encourage students to use AI in their education? And will AI become the great, and proficiency at using AI, become the great differentiator between success or failure in the classroom and then success or failure in the workplace?
I think it's a good idea for teachers to encourage the use of AI where it's appropriate. I think the trend that I've been seeing in higher education, at least, has been to mix AI with sort of more live face-to-face activities. So maybe you use AI to help with your research and you submit different milestones along the way so your teacher can guide you and help you write that paper, because that's how it's going to work when you graduate. But that final exam, that might be an oral exam where it's you and a teaching assistant or you and your professor up at a chalkboard working something out to prove that you actually have the fundamental skills as well. I think students need both. And so we have to prepare them for the world they're going to go into. And that means having both the fundamental skills and the practical skills to work with these things in the real world.
Alfred Whitehead, thank you very much.
Thank you.